Hi, today we're going to talk about potential energy problem set 1 worksheet. The equation for this worksheet is PE, potential energy, equals mgh, so that's mass times gravity times height. Remember, while we're doing this worksheet, you want to use the guess method, so you'll write down your givens, your unknowns, your equation, you'll substitute, and finally you'll solve. And of course you will include a unit. Number 1. Legend has it that Isaac Newton discovered gravity when an apple fell from a tree and hit him on the head. If a 0.2 kilogram apple fell 7 meters before hitting Newton, what was its potential energy before the apple fell relative to the ground? So I'm going to go ahead and write out what I don't know. I don't know that potential energy. My mass is going to be 0.2 kilograms. My gravity, I know, is 9.8 meters per second squared, and my height is going to be 7 meters. I'm going to write down my equation, and now I'm going to substitute in what I know. So my mass is going to be 0.2 kilograms, and I can get that from here or from my equation. My gravity is going to be 9.8 meters per second squared. And again, that's not in the reading part, but that's something that we know that occurs on Earth. And my height is going to be 7 meters. So I'm going to take my calculator, and I'm going to plug those numbers in. So 0.2 times 9.8 times that 7. And it's going to give us 13.72. We're talking about potential energy here, so we know energy is measured in joules. And that's it for number 1. Number 2 says, it is said that Galileo dropped objects at the Leaning Tower of Pisa to determine whether heavy or light objects fall faster. So that's a typo right there. If Galileo had dropped a 5 kilogram cannonball to the ground from a height of 12 meters, what was its potential energy? So I'll write out, I don't know what my potential energy is. My mass, I know, is at 5 kilograms. My gravity is still going to be 9.8 meters per second squared. And my height is going to be that 12 meters. I'll write out my equation, and I'll plug in these numbers that I know. So mass, 5 kilograms. Gravity, 9.8 meters per second squared. Height, 12 meters. Now I can plug those into my calculator. 5 times 9.8 times 12. It's going to give me 588. And of course, it's joules because we're talking about energy. Number 3. Blackie, a cat whose mass is 5.45 kilograms, is napping on top of the refrigerator when he rolls over and falls. Blackie has a potential energy of 85.5 joules on top of that refrigerator. How far will Blackie fall? So this one might be a little bit more tricky. So let's go ahead and write out all our givens and our unknowns over here, and we're going to piece it all together. So mass is 5.45 kilograms. Energy is going to be 85.5 joules. Gravity, I'm assuming Blackie the cat lives on Earth, so it's 9.8 meters per second squared. How far is he going to fall? So that's what we don't know. I'll write in my equation and substitute what I already know. So I have 85.5 joules. My mass is 5.45 kilograms. My gravity is 9.8 meters per second squared. And my height, well, I don't know that height. What I like to do is combine these terms before I divide. So I'm going to go ahead and do that on my worksheet. So I'm going to have 5.45 times 9.8, which is going to give me 53.41. So 53.41 kilograms times meters per second squared times my height, and that's going to be equal to 85.5 joules. Now I'm going to go ahead and divide this side by that 53.41 and divide this side by 53.41 in order to get height on its own. So this will cancel out. You could go ahead and figure out what makes up a joule and then cancel this information as well, the unit information. But for the sake of our class, we're just going to remember that height is dealing with meters. So I'm not going to worry about that part as of yet. Go ahead in your calculator and plug in the 85.5 and divide that by 53.41, and it's going to give you 1.6. So 1.6 meters. And that's our number 3. Alright, so we're going to move that sheet up so you can see a little bit better. And we'll continue with number 4. A high diver at the top of a 10-meter high dive platform has a mass of 50 kilograms. What is her potential energy relative to the water? So it tells me, I don't know that potential energy. I'm looking for that number. The mass is going to be 50 kilograms. The gravity on Earth is 9.8 meters per second squared, and our height is going to be that 10 meters. I'll write in my equation, and I'll substitute in what I know. And I can multiply out all my numbers. So 50 times 9.8 times 10. Okay. And of course, that's going to be in joules. Last question for this sheet. Neil Armstrong, who is an astronaut, has a mass of 80 kilograms. What is the acceleration due to gravity? So it's saying, what is this acceleration due to gravity if when he jumps up 5 meters and gains a potential energy of 668 joules? So since it's asking us to solve for this gravity, I'm going to go ahead and assume that Neil Armstrong might not be on Earth. So we'll write this out. PE equals the potential energy gain was 668 joules. His mass is going to be 80 kilograms. His gravity, we do not know what that is. And our height is going to be 5 meters. So we'll write in potential energy. We'll have 668 joules. The mass is going to be 80 kilograms. We don't know G. And we have 5 meters. You could go ahead and rearrange this equation because when you multiply something, it doesn't matter which order it goes in. I'm assuming that you know that so far, so I'm just going to go ahead and multiply 80 times 5 to get that number together so I can get prepared to divide on this side. So I'll do 80 times 5 is going to be 400. So I'll do 400 kilograms times meters and leave G on its own. And then I'll still have 668 over here. And now I can just divide each side by this 400. So we talked about this once before. You could go ahead and break down a joule and figure out what units are in there. But we're not going to do that for the sake of this class. But you do need to remember that gravity is going to be measured in meters per second squared. So I'm going to write in that unit at first. And then I'll go ahead and divide. So 668 divided by 400 is going to give me 1.67. So it's 1.67 meters per second squared is my gravity. And that's all for the potential energy problem set 1 sheet.